Okay, we're filming. Are we filming? We're cool. We're cooking. Okay, we are on the air. And is that important? Is that going to consume your face? You're getting up out of your seat, walking from the back of the room to the front, throwing something away. Don't do that. Okay? It's rude and obnoxious. It is. Okay, it is. I think it is. So this is the question. Let's repeat the question for the home audience, which may be you in a few hours. Using direct evidence, is the sun hot or is it bright? And we've established that it's bright, not hot, because we can't take the temperature of it directly. So how is it heating? How do we heat? How do we heat the earth with something that's bright? And the last question we asked before I turned on the camera was, how does heat go from one place to another as well? So there are a lot of questions we want to answer. There are additional questions we want to ask. It's all about the question. I couldn't get through 2 lectures ago in here because you guys had so many questions, which are excellent. It's all about the question. So please feel free to ask the question. Understood? Okay. So what's the last question we asked? Well, the last question we asked before I turned on the camera was, well, all right, we have to figure out how heat travels. Well, the heat travels in 3 different ways. The first way is conduction. Conduction touching. This is hot. Oh, God, that's so hot. Oh, it's cooling. Okay. Conduction, direct contact. Correct? Direct contact. Yes? Okay. Heat can travel through convection. Back in the United States, as in here, air conditioning is in the ceiling and it comes down. Correct? It comes down. Say that again? No, it comes from the ceiling. Why does it come from the ceiling? Sure, some of the air conditioning will come from the floor, but I don't particularly find that that's very useful, and I'm going to tell you why. Yes?
Isn't it the reason why heaters are on the ground, or like, what's the cold thing that makes it warm? You have in Europe, we don't know what that is here.
Radiators?
Yeah, they're down because heat travels upwards.
Okay.
Yeah, and the cold comes down. So that's why ACs are up and the radiators are always on the ground.
You see, it's amazing. You already know that based on your experience. So there's really nothing I have to teach you. I simply have to draw it out of you. And she's correct. If you thought about it just for another 30 seconds, you would have come up with the same idea. Here's a room. We know that cold air, things that are cold, are more dense than things that are warmer. Correct? If it's the same thing. In other words, air. Cold air is more dense than warm air. Correct? So the density of air going from cold to hot, you are increasing what? You're increasing the what? The mass is the same. Remember, density equals mass over volume. So what's increasing as you go from cold air to hot air?
The density. Everything's moving more.
Volume. You're going from cold air to hot air.
Oh, yeah.
You're decreasing. But what are you increasing? What are you? No, what are you increasing? You're increasing the volume. You're increasing the volume. According to what law? Temperature, pressure. Temperature, pressure, no, that's not right. Temperature, volume, right? Temperature, volume. Charles' law. Let's go over here for a minute. Charles' law. French chemist. He said that volume is proportional, direct, linear to temperature. If I take a balloon and I heat it, what's going to happen to the volume of the balloon? It's going to expand, correct? So the volume is increasing. So what happens as a result? Let's look at the ratio. Density equals mass over volume. Is the mass going to stay the same? Yeah, given a certain amount of air, constant mass, if I expand, you guys finished? Excellent. If I have a certain quantity of air, let's say it's a certain mass of air, is the mass going to change? No. Let's pretend this is a balloon. It has a certain mass of air in it. Okay? Yes? The mass is going to stay constant. The mass of the air inside the balloon, for instance, is constant. What's happening to the volume? It's increasing. So what's happening to the denominator? We're not talking about pressure. The pressure is constant. What's happening to the volume? It's increasing, isn't it? So what's happening to this ratio? What's happening to the quotient defined by density? It's increasing. Yes? Volume increases. What's happening to the density? It what? Increases? It decreases. Density decreases. Mass is constant. Correct? Yes or no? A little bit of physics and chemistry. Important. Charles' law. Increase temperature, increase volume. They're proportional. It's a direct relationship. Why am I going over this? I'm going to explain. The whole concept of convection is based on this. Differences in density. How is that important relative to the movement of heat? We have conduction, but what about convection? Let me get something to wipe the board. Well, all right, let's erase this. So, we have a room. We have AC up here. We have heat here. The heat is going to do what? The heat is released at the bottom of the room, at the floor. The AC is released at the top of the room. What happens to the cold air? It's going to sink. Why? Because the air is colder. The volume is less. Think density.
So the denser?
The denser air will fall, correct?
Yeah.
Denser air sinks. That's cold, right? So this is cold air. It's going to sink, isn't it?
Yeah.
Yes? If I have wood, will float in water. Why? The wood is less dense. A piece of lead will sink in water. Why?
More dense.
The lead is more dense. Water is the same as air. They're both fluids. More dense sinks in less dense. Yes?
Does that cause water temperatures like I don't know, low or
I'm not sure. Is there a question there?
yeah, like what causes water to move temperatures?
What causes water to...
Like the humidity and all of that.
We're not talking humidity. We're not talking about humidity at all. We can't have that many variables in here. All we're talking about is the temperature of the air. We're suggesting that humidity isn't a factor here. Okay, it can be a factor, and temperature can be a factor, but we'll go crazy. All we're doing is we're focusing on two things: density of the air based on temperature, and transfer of heat. Yes? Okay. So, in the winter, in the summer, you're going to put the AC, it's going to fall. When it gets down here, it's going to do what? When it gets into the room. Okay? When it gets into the room, it's going to do what? It's going to warm up, isn't it? Right? It's going to warm up, and what's here? That's the outtake, right? The air is sucked out. Goes up through the AC, condenser, right? The condenser. We're not talking about condensers. We're not going to talk about what it is, but it just sucks out the heat, right? Because this falls down, the warmth will go into the air, right? That's why it warms. It'll get sucked out. The heat is taken out by the condenser, falls in, and you get this cycle, correct? Yes? Right? So we're transferring heat. Yes? We're transferring heat. What happens? That's AC. But what happens in the winter? In the winter, what happens? It's going to come here, it's going to rise, isn't it? It's going to cool, it's going to rise, it's going to cool, and you're going to get this cycle. Yes? Now you can also have these outtakes in the ceiling, and it'll rise, you know, but it'll cool. You're still going to have the outtakes here because it's going to get this circular motion. That's convection. It's convection. That's convection.
So it like goes up and it goes circles?
Yeah. You get this circulation. You're not creating a hurricane in the room, but you get this convection current in the room. Now, we're ignoring modern technology, etc. Let's just say we have a coal stove, it's 200 years ago, and we have the heat being produced at the floor. It rises, warm air rises because of density, correct? Then it cools, it comes down, is reheated, takes the energy, right? And circulates and creates this warmth throughout the room. How does the warm air get from over here to over here?
Circles.
How does it get from the floor up here? Through convection. So heat can be transferred through convection. Okay, through convection. So right now we have heat being transferred by conduction, touching, and by convection, by changes in density of the air that is going to create the circular motion or some kind of movement where energy can be transferred. Yes?
So what's the dictionary definition of convection?
You look it up. She's going to look up a dictionary definition of convection. Let her, and we'll listen to the both of you. Now, while she's doing some research, let's look at radiation. What is radiation? The best way to look at radiation is by examining very briefly, Anna, the greenhouse effect. It's a wonderful example of radiation. Okay? When you hear the word radiation, how many people think something horrid? Radiation poisoning, the nuclear bomb created radiation sickness, Chernobyl, the town that housed the workers outside Chernobyl was called Pripyat. Thousands of workers lived there. It's a ghost town because of the radiation. Why is the word radiation so horrid? Well, It's a very misunderstood word because radiation is simply, solely and only a type of energy transfer. For instance, here I have the sun. The sun is bright. Here I have the earth. And around the earth I have a thin, I'm going to make it thicker, but a thin veil we call the atmosphere. Okay. Easy? Okay. The sun's rays, the visible light rays, they're short, correct? We'll look at that in a moment, but visible rays are short. The road in the summer, hot or cold?
Hot.
That heat is re-radiated. The sun shines on that road. The road is black. The road re-radiates that energy as heat. The road re-radiates that energy as heat, correct? That heat is heat. It's infrared radiation, isn't it? Yes? Infrared radiation has longer wavelengths. Those longer wavelengths can't get out of the atmosphere. The short wavelengths can get in, but the long wavelengths cannot get out. Bounces back. They bounce back. They get trapped. What's a very small example that you use every day that demonstrates the greenhouse effect? It happens every day. I ride to school in the morning and I don't even turn it on. Nope. AC, but what does that have to do with what I'm talking about? Well, if I'm driving during the day, when it's hot, this is Abu Dhabi, right? It's hot in the summer. Has anybody noticed that? Have you noticed that yet? That it's really hot in the summer here? Okay. All right. Well, I'm driving down the road. I'm going to go to El Wada Mall downtown, right? And I live here in Khalifa City. And I have that AC blasting. And I don't want to park in the garage underneath the building. You know what I want to do? I want to park outside because you got to pay now to park in El Wada Mall starting on the 28th of September. Did you know that? Really annoying. It is. So it's cold. It's almost freezing, but I'm enjoying freezing in my car driving to El Wada Mall. Right? And I get there 11 a.m. I got a lot of things to do. Maybe I'll catch a movie. You know, Muhammad and I are going to go see The Maze Runner. I hear it's really good. Excellent. Now, I get back, and the car is so hot, we have to kind of open it up a little bit and air it out and turn the AC on and let it cool out, and then we can finally get in. Right? What happened? Why did it get so hot? It was so cold in there. How did the inside of that car get so hot? I didn't open the windows and pour in heat, did I? Was there a heater on inside that car? No. So how did the heat get in there? I didn't. How did it get in there? I didn't like. Somebody came along and, you know, reversed engineered. I don't know. How did they put heat in the car?
The car is shiny.
The car is shiny?
No. So it attracts the heat, so it goes in, but
the heat goes in like that? The heat goes in like
heat.
I want heat.
No.
This is